June 15th, 2026. Now, I know that might seem a little ways off, but if you build apps or services that rely on Google, well, this is the exact date a massive system-breaking failure could literally take down your infrastructure. If you're not prepared, that is. The clock is officially ticking.
Welcome to The Explainer. I'm your host, and today we're breaking down a major upcoming security update from Google Cloud. Look, I get it. Terms like TLS certificate transitions sound incredibly dry and honestly super technical. But stick with me here. We're going to make it crystal clear exactly what this means, why Google is doing it, and most importantly, what developers need to do right now to keep their apps running smoothly.
Okay, let's dive into this. Here is our quick roadmap for today's Explainer. 1. The 2026 security shift. 2. TLS and certificates. 3. RSA vs. ECDSA. 4. Why apps might break. 5. A really handy guard analogy. And finally, 6. Your developer action plan. Let's get to it. Section 1. The 2026 Google security shift.
So recently, an email went out from Google Cloud detailing this massive overhaul of their security certificates, culminating in 2026. And here's the reality. If companies just ignore this update and don't adjust their code, things are going to break. And fast. Imagine your users waking up to this kind of nightmare. API connections? Failed. Logins? Failing left and right. Your Google Maps integrations? Completely broken. Your Firebase backend? Disconnected entirely. I mean, wow. This isn't just some hypothetical bug. These are real-world disaster scenarios just waiting to happen if you brush this transition off.
Section 2. Understanding TLS and certificates.
Okay, let's just slow down for a second and look at the foundation of all this. How do our browsers and our apps actually know that a website is real and not just some clever fake? Well, on the user's end, it's actually beautifully simple. When you go to a secure site, like Gmail, YouTube, or Google Cloud, you see that little padlock icon right there next to the URL. And that padlock means the SSL or TLS certificate is valid and verified. It's basically the digital equivalent of a passport check, just ensuring that you are securely talking to the actual, real Google.
Section 3, RSA versus ECDSA explained. And this brilliantly illustrates what we're talking about today. Because right here, this is the absolute heart of Google's big transition. They are fundamentally changing the underlying math of those digital passports. Basically, Google is moving away from the old encryption technology, which is called RSA, and they're transitioning over to ECDSA. RSA is, well, it's heavy, it's slow, the certificates themselves are physically larger, and it eats up high bandwidth and CPU. ECDSA, on the other hand, it's new, it's modern, it's incredibly fast, and it is totally lightweight on both bandwidth and processing. So Google is making this shift specifically to improve global performance and processing speed across literally all their services.
And as part of this modern shift to ECDSA, Google is also introducing a new intermediate certificate authority. So pretty soon, you're going to start seeing Google Trust Services WE1 acting as the new digital issuer that's actually stamping these faster, lighter certificates.
Section 4. Why apps might break.
Now listen, if you are just an everyday user watching YouTube or checking Gmail on your browser, you can absolutely breathe easy. You don't need to do a single thing. But for you developers out there, if you've configured your applications in specific, rigid ways, well, the alarm bells should definitely be ringing right now. The first major culprit is a practice known as certificate pinning. What is that? Basically, it's permanently locking an app to trust only a specific hard-coded certificate. And, some developers do this thinking it gives them this extra layer of impenetrable security. But actually, scratch that. It creates a massive, really brittle vulnerability when those certificates inevitably need to be rotated. Because here is the underlying logic. If your application is hard-coded or pinned to look strictly for that old Google RSA certificate, what exactly happens when Google flips the switch to the new ECDSA certificate? Well, a complete mismatch. The app essentially says, hey, I don't recognize this new passport, and it completely severs the connection to Google. No way around it. The second big reason apps might break involves custom trust stores. This is a custom, non-default list of trusted certificates built specifically for a company's internal apps. Normally, our devices just use their operating system's default list of trusted certificates, right? But custom enterprise apps that only trust the old Google root CA will soon start throwing untrusted certificate errors. Why? Because they literally just don't have the new Google issuers in their custom database yet. Section 5. The security guard analogy.
Okay, if that tech jargon felt a bit dense, let's try to imagine this everyday scenario. Think of an office building. The building's security system is explicitly programmed to solely trust Guard A at the front desk to verify employee entry. If Guard A says you're good, the door's open. Simple enough, right? But now, let's say the company upgrades its security team and replaces Guard A with a brand new hire, Guard B. But the building's computer system wasn't updated to actually recognize Guard B. So even though Guard B is perfectly legitimate and, probably makes great small talk by the water cooler, the computer system just blocks everyone. Access denied. And this is exactly what happens with these new certificates if your app's internal security desk isn't updated to recognize the new Google authorities. So whose employees are getting blocked here? Here are the systems at the highest risk of being denied access. We are looking at old Android apps, custom enterprise software, highly sensitive banking systems, IoT devices deployed way out in the field, rigid corporate firewalls and proxies, and Java applications running with custom key stores. Look, if you manage large-scale enterprise systems, you absolutely need to be auditing these exact areas.
Section 6, the Developer Action Plan.
All right, developers, it is time to grab your notepads. Here is your actionable survival guide to make sure you sail through this transition without a single minute of downtime. You have 4 exact steps to take before June 2026. Step 1, remove pinning. If it is at all possible, disable certificate pinning entirely in your codebase. Step 2, add Google routes. You must ensure all Google Trust Services root CAs are actually added to your trust lists. Step 3, update apps and libraries. This means actively updating old SSL libraries, OpenSSL, your Java key stores, and your Android network security configs. And finally, step 4, test and staging. Get this into a testing environment well before that 2026 deadline to ensure everything connects perfectly. So the crucial point is this. Google's official best practice recommendation for long-term app stability really comes down to this. Yes, for sure, trust the root CAs, but absolutely do not pin intermediate or leaf certificates. Certificates rotate, they expire, they upgrade to better encryption like ECDSA. Pinning the leaves is just a guaranteed way to break your app down the road. Because, look, if you fail to implement this action plan in time, these are the exact terminal errors you and your users are going to be staring at on a Monday morning. SSL handshake failed, certificate verify failed, unable to establish secure connection, API timeouts, connection refused. I mean, it is an absolute nightmare scenario for any operations team.
So we've covered the why, the how, and the genuinely dire consequences of Google's massive shift to ECDSA certificates. The clock is ticking toward June 15th, 2026. Codebases that rely on outdated pinning or rigid custom trust stores are, well, they're essentially sitting on a ticking time bomb. So I leave you with this one absolutely critical question. Will your app survive 2026? Audit your codebases today. Thanks so much for joining me on this explainer, and I'll catch you next time.